Welcome back. Today we're going to look at the second half of section 3.3. We're still working on solving systems of inequalities. Our focus today will be on inequality systems that contain at least one absolute value graph. So we're going to follow the same rules as when graphing lines, but remember that you graph absolute value functions using the transformation idea. And those should be a V shape instead of a line. So let's look at our first example. We have y is greater than or equal to x minus 4. That is a linear equation in slope-intercept form. So we're going to go ahead and graph that starting at the negative 4 and doing a slope of 1. I'm going to go ahead and color code these so we can follow along afterwards. We are starting at negative 4 and we're going to do a slope of 1. So up 1 and right 1. And then we do have to focus on whether it's solid or dotted. Since this one has an equal sign, we're going to make a solid line through that. And then we want y also to be greater than that line, so we are focusing on shading above the line. Then for our second inequality, this is an absolute value one. We graph that using the transformation idea. So our first piece here, we're going to reflect over the x-axis, which means our v is going to be upside down. We are also moving it left 1 and up 2. So our vertex, instead of being at the origin, is going to go left 1 and up 2. And then we did reflect it, so it's upside down. This front number here also represents the slope on the right side. So we have a slope of negative 1. So down 1, right 1 for our negative 1 slope, and then down and back to get the opposite side. This one has no equal sign, so we are going to make this dotted. And we want to be less than that, so we are shading below the line, or below the V. So if we look for the place where they overlap, where both things are being shaded, we have to be above the blue line but below the red V. So we are looking at shading all of this section. All right, for our second example, again, our first inequality is a line. We have y is greater than 1/2 x plus 3. So starting on our y-intercept of 3 and do a slope of 1/2, up 1, right 2, or down 1 and back 2. There is no equal sign, so this time our line is going to be dotted. And we want to be greater than that, so we are shading above that line. For our second one, we have the absolute value. This time we are going right 2 and up 1. There's been no change. We still have a slope of 1 in front. So right 2 from the origin and up 1. And we're going to do a slope of 1 on the right side and negative 1 on the left side. And then this one is going to be a solid V, since there is an equal sign with it. And we want y to be less than that, so we are shading outside of the V. So looking for where they overlap, we want it to be above the above the blue and below the red. So below the red, let's go ahead and extend this out. We want to be under here, but above the blue. So we are looking at the points in this region. So it is important that you somehow indicate where the two inequalities overlap. So make sure if you're shading these at home that you are doing it lightly so that you can darken in that final section. All right, what's different about this one? Our first equation, or first inequality here, is still linear, but notice it's just y is greater than or equal to 5. You can think of that as 0x plus 5 if that helps you. We are starting at a 5 and our slope is 0, which means we're rising nothing, but we are running. So we end up with just one of those horizontal lines. All right, y equals 5 is a horizontal line at 5. We want to be greater than or equal to 5, so we are shading above. Then for our second one, we're back to having an absolute value. We did do a vertical stretch of 2, which means the slope on the right side will be 2. We've moved right 3 and up 1. So let's go right 3 and up 1. We're going to do a slope of 2 on the right side, so up 2 and right 1. And then up 2 and back 1. This time it will be dotted because there is no equal sign. And we want y to be greater than that. So we are shading inside the red, absolute value v, and we want to be above the blue. So we are looking at this part right in here. Okay, above blue but inside the red part. All right, our last example for today. Our top inequality, x is less than 4. We would have a vertical line at 4. This time it is dotted. And we want all x values that are lower than 4. So 3, 2, 1, 0, etc. We are shading this side. For our absolute value graph, this time we have a reflection because of that negative, a reflection over the x-axis. We've done a vertical stretch of 2, and we've moved left 4 and down 1. So our vertex is going to go left 4 and down 1 from the origin. And then we want to do a negative 2 slope on the right. So we're going to go down to right 1 and down to left 1 to get the opposite side. There's an equal sign on this one now, less than or equal to, so we are going to look at a solid V. We want to be less than or equal to it, so we are underneath our V. So we have to be underneath the V and to the right of the blue line. Now, that may appear as if we are just looking at this part, but we have to be under red and to the left of blue. And if we extended this even further down and we extended our V even further down, you can see that we are going to have quite a large section here that would be shaded, all of this, up until we hit that vertical line. All right, so you are going to practice this skill with a worksheet. It should be 3.3b.